Dear learners, welcome again. So, in the last three lectures, we have discussed about descriptive analytics. We have seen step by step how we used to calculate descriptive analytics using manually. Then we have seen the descriptive analytics in R also. So, in this particular lecture, I'll be discussing about the two of the law which we have discussed in the previous week. One is Bradford law and another is Lotka law. So, we will be doing the practical of Bradford law and Lotka law in R. Okay. So, we have already discussed the theoretical part in the last week. So, as you know that the Bradford law is one of the popular law and the theoretical distribution for assessing the scientific productivity. So, what exactly it is? So, Bradford law shows the relationship between the journals and the number of articles published in a subject. Okay. So, it was studied by Samuel C. Bradford in the year 1934 when he studied the publication of geophysics and lubrication, and he identified some patterns in on those publications. What pattern it was? So the pattern is that if we arrange the journals in decreasing order of their productivity, then we can identify three zones of the journals. Okay. So what all these three zones are? So first is the core zone, which we call it as a nucleus zone, where we have a less number of journals which have almost one third of the publications. Okay. Then we have the second zone which have more number of journals compared to the core journals, but it has close or equal to the number of publication what the first zone have. Okay. And in a similar way, we have a third zone which have more number of journals compared to the nucleus and then our first zone, and it also have close or equal to those number of articles. Okay. We have already discussed these theoretical part. Now we'll see as a practical part. So for doing the Bradford law, we need a package because we have seen that lot many calculation we have to do. So there are like no inbuilt function are there to do this kind of computation, but we have some packages. Okay. So that package is bibliometrics. So if you don't have the package, you can install it. So how we will install the package? Either by calling the command install.packages, and under those bracket we will write the name of the package, or by going to the GUI tools and we can install the package. Also we can search about this package on this URL. Okay. So on CRAN page we'll go here, then we'll go to the this package by names. We'll search here bibliometrics, and this is our package and we can install it. Okay. So after running this thing, our package will be installed, and after installation of package we have to call that, and to call that package we will be using the library. I'll calling this package. Okay. I hope package is installed. Now we need a data to do the analysis. So one is that way that we have to extract the data from the bibliographic data sources like Scopus, Web of Science or PubMed. But for the testing purpose, we have some data set. I have already discussed that each package comes with various things like documentations, then data also. So the same way the bibliometrics package has also have some data. So this is that function which we will be using to call the data. So if I run this, so these are all data set available in the current bibliometrics package. If we want to know about this data function, so what we will do? We will use the question mark. So we'll use this, and help is there. So this is the way you can call the data, and it is showing that how you have to exactly call, and what are these documentation. Okay. Then we want to know that what all data set available are with all the packages. Okay, so we call the data function like this, where we will say that where whichever package has the data list all those things. So if I run this, okay, so it's showing that there are data set in package bibliometrics. So these are the data set. Then there is another package bibliometrics data which have these many data set: management, scientometrics, and scopus collection. Then we have, like in my system, there is another package bit 64. Then we have this cluster one package is there. Like that, whatever the package we install, the data set of that package we can see. So this was we have installed in the previous lectures. So these are the data set available, and we can use these data set for our understanding of the analysis. Okay, so if we have to see the data set of a particular package, how we will see? So we will name the package. So these are the data set available in this package bibliometrics. Now for for our analysis we need a data set. So there is a package called bibliometrics data. Okay, and in that package there are some data set is there. Okay, so these are the some of the data set we will be using: management and scientometrics. So we will be using management for the Bradford law, and then we will be using scientometrics data set for doing the Lotka law. So it is showing here some description also, that management, the use of bibliometric approaches in business and management discipline, and then we have scientometrics dataset, co-citation analysis, coupling analysis, manuscript. Okay, so make sure that whenever you are running these commands, whenever you are calling in this way, the package should be called. Okay, package should be called, and also the package installed. Okay, without installation calling of that package, there is no meaning. So and we can also see these things in our system also, that where those data is. Okay, so each package comes with a data set, and those data set are on the our where the package is installed. So we'll go to that directory. So this is that directory. If I copy this and open it here, so just you copy and paste it here. Okay, so this is the library of all the packages we have installed. So for us, there is bibliometrics, and this is a data directory is there, and these three data set are there. Then if I go to my bibliometrics data here, so here we have this data. Okay, this management data or scientometrics data. Okay, so if you see here that you have just run one single command, install.packages. Okay, and that single command not only installed those all those code, but whatever the things like packages and other data set, and also the manuals by also are installed and stored in your machine. Okay, so for Bradford law, we will be taking the management data. So how we will call that? So this is our data set. This was our data set in bibliometrics data, and in under bibliometrics data we will be using management. So we have to use this way data, then we have to mention management. So we are using management, and where it is, so it is in the package bibliometrics data. Okay, so I run this. Okay, so my that data is imported here. Now what we used to do first thing after importing the data, we will view it. So we will first view what that data is. Okay, so I'll run this here, and this is my data set is there. Okay, if you see this AU stands for authors, then these all those metadata are there. Then this if we go here, this is the DOI, then document type, whether it's article or we'll see all are article. Articles, some are proceeding papers, articles are there. Okay. Then for Bradford law, we are interested in the source. So where our source is? Yes. So this SO stand for source. Source means our journals. So these are the journals. If you see here, so these are all journals for this data set. We will be using this. And if you see here it is showing that there are 898 entries are there in this data set and 67 total columns are there. Okay. So these 67 columns names, we can identify the column names and the number of rows also. So as a practice, you just let us know in the discussion forum how you will able to identify what all different column names are there and what all different rows are there, what exactly the dimension of this particular data set in R. Okay. So this is our data set. So management is already there. So after viewing the data set, what we have to do? Then we will do the analysis. So to do the analysis, we must know that what function we have to use, what function name, the way we have searched for the maximum, minimum and all. So each package has their own documentation and there they declare that okay, you have to call this function name for doing the analysis. Okay. So for that, if you go on this page, this is the reference manual, and if you write here Bradford, it's on the 12th page. So we have to call this function Bradford. Okay. And if you notice here, there is only one argument. It doesn't require two or three arguments. We have already discussed the one argument function, two argument function. So here only one argument. What that argument is? A bibliographic data frame. Okay. So here our data frame is this management, and that's the function Bradford. If I run this, okay, that is done. This is our result is here, but I assign to one object. Okay. So I am assigning the whole computation and analysis into an object, named it as Brad result. Okay. So if I run like this, Brad result. So if I see the output of this, okay, graph is there. Just I'll hmm. Now let us see what exactly the class of this object. Okay. So this is a list. We have already discussed that many of the functions give the output in the list. So this is a list. Now see what exactly the number of elements are there in the list and what exactly their names are. So what function we use to see the names of the element in the list? We use the names function, and we will call like this. So this is the name function, and here we have to give the this object. So if I So table and graph. So see, we have discussed when we were discussing about list that list is a flexible data structure. Okay, where you can not only store data frame on a vector, but here we have stored table and a graph also. Okay. Now for table, we'll see that what exactly the names are there. So if I do like this, so under table there are these 5 columns are there. One is SO, rank, frequency, cumulative frequency, zone. Okay, and so we'll see what exactly SO is. So the same way like what we have discussed in the previous lectures, that we will be using the dollar sign. So this is, if you see, this is our list, then we will put the dollar. So there are two options. So under table we want to see that, then there are multiple options. Okay. So I am seeing SO. If I run here it again, all those sources are there. So these are 281. Then if I have to see the rank, so these are the rank, and then I have to see the frequency. Then I can say this cumulative frequency. Then the zones. Okay, so whole data set is divided into 3 zones. So if you see, only few of the journals are in the zone 1, then some more journals in zone 2, and then in the zone 3. Okay, so zone 1 is our nucleus. Okay, we'll see through our table also. Okay, so now we will convert this as a data frame. So we can easily create the table into a data frame. How we will do that? We will use the data dot frame, and this is our table. So if I run like this, so this is the name of the journal, and then it's showing that what exactly that zone is. Then let us first create this data frame. So our data frame is created. Now if I run this, okay, so this is our data set. Now there are only 5 columns. So one is the source name, then the rank, then the frequency, then this cumulative frequency, then what zone is. Okay, now our analysis is done. Okay, now we will export it as a external CSV file. So how we will do that? Write.csv or read.csv? No, we will be using write.csv, because read.csv we use for importing the data set, but for exporting the data set we will be using write.csv. So write.csv, so this is this thing. Then we'll mention the file name, and again here you have to remember about that the location of the file. Okay, so my current directory is document only, so I am only mentioning that Brad result. But if you want to save this data set in another location or desktop or download, so you have to give the either the complete path, or you have to change the directory to that particular location. Okay, so our this data set is there. Now I'll run it this like this, and my file is created. Okay, now we'll see the file here in documents. Okay, so these are the sources, and these are the, if you see, rank, and then these are the zones. Okay, if you see that only these many 8 journals are there in zone 1. Okay, it has 305 number of articles. Okay, then so zone 1 has 8 journals, and the number of articles are 305. Okay, now we'll see the zone 2. So in zone 2 we have 65. So in zone 2 we have 65 journals, and then we have 604. So 604 minus 305, 299. Okay, then we'll go for zone 3. So in zone 3 how many journals we have? 208. And the number of articles we have, so it has total are 898. So 898 minus this 2 will be 294. Okay, if I see here, this total is 898. Okay, so these are our three zone. So this zone 1, this is our nucleus. Okay, this is our nucleus. These 8 journals is our nucleus. Then if you see here, that zone 1 has the less number of journals, but one third of the those articles. Similar way, zone 2 has more number of journals. It's close to 305 only. And then we have in zone 3 208 journals. Okay, so this is what a Bradford law is. Okay, this is what exactly the Bradford distribution. Okay, so now the question comes that whenever we discuss about the R and its packages, we say that R is an open source and packages are its open source. What exactly that open source mean is? So the open source mean is that it's available for free, but your code is also available. Okay, you can edit the code. Okay, so here what we have done, this function is already created. Okay, if you remember when we have created the addnum function or Mohit function or Mukesh function, we have created and we have given the command. Okay, we have to print this. Okay, but this function is the main thing which calculating whole this analysis. So we have to see how this function is doing all the computation. Okay, and because this package is an open source, so all that code is available. How we will see that? So we'll go to here. So this is our code page, and here if I go on under R, I can see there are lot many. All those what are the computations are there, those functions are there. Okay, so what we are doing is we are doing for Bradford. So if you see on this code, they have used the comment option, this hash. So it's showing that this is a Bradford law, and the formulation is that if a four journal in a field are sorted by number of article into 3 group, each with about one third of all articles, then the number of journals in each group will be proportional to 1 is to n square. Okay, so this is our code. Okay, this is our function. Okay, so we have created only like 1 or 2 argument functions and with 2 or 3 lines, but here if you see there are many lines. Okay, so they have developed this wonderful package and they have written the whole code, and this whole code is free. You don't have to pay any kind of amount to access this. Okay, only thing is that what I mentioned in the starting also, that whenever you are using R or its package, you give the citation. At least acknowledge that they have done this much contribution, and because of them we are able to do this analysis. Okay, so we will understand a bit about this code, because if you see here, this Bradford function just generated this graph. Okay, and in one way you can just simply export this graph, save as image, or this rplot04, and say for example I name it as, Bradford. Okay, so it's created, but you see it's black and you want to change the color and or maybe this heading or anything. Okay, so for that that function doesn't provide anything. Okay, means you can't assign that you change the color, or you can assign your different font size. Okay, so for that, you must understand that how that function is working. I'm not saying that you must go through the whole code, but some of the key things which will be helpful in designing this visualization in a better way. Okay, we will be learning about data visualization in the upcoming weeks, but just see how exactly if we understand this function code, we can easily change this whole visualization. Okay, at least we can change the color or the legend and all. Okay, so I am copying this code. So I am copying this code. Okay, and after copying it, I am pasting here. Okay. So I have copied that whole code and I have named it as a new function name. Okay. So I'm just making it as new Bradford law. And now this is my function. Now on the same data set, we won't call Bradford, but we will call it as new function. What name we have given? New Bradford. So if I run this, so we have not created the new Bradford. Okay. So it automatically pop out that first you create the function. So what exactly our new Bradford is? So new Bradford is this. Okay. Now if I run this and I'll assign to an object. Okay. Oh, could not find function AES. So it's because we haven't called the another library ggplot2. We'll call the library ggplot2. Now if I run this, and now I hope I'll run this again. And now if I run this, I hope it won't show any error. Okay. So the thing is created and this is our new Brad results. So this new Brad result is a new object which have the output of a Bradford computation, but based on the new function. It's the same function. We have just copied, but only changed the name of the function. But the results are same. But now we will make it some changes in this function so that we can change some color and all those things in the this graph. So if you see the class of this new Brad results, it's a list. The same output what we got there. Now if I change the color, so here if you see black is written. Okay, instead of black if I write green. Okay, now I'll run it again. Now if I run this, okay, if you are able to see this, the color is changed. So this is a green color. Earlier it was black. If you see, this was a black color. So this is another important feature in RStudio that you can just go around that what was the previous visualization and what is the current visualization. Okay, so this is our current visualization. So we have changed this to green. Now maybe now you want to remove this logo. Okay, so but I recommend that whenever you are using this code and this package, please don't remove the logo. At least it's a small contribution to their work that what wonderful uh, thing they have done to develop this package. Okay, so if I do like this, if I do like this, and now if I run this again, okay, so this logo is gone. You can put your own logo or something else is there, but do cite this particular package if you are using this whole code. Now if you want to change another color of maybe, so so these are what exactly mentioned here is the hexadecimal code. Okay, instead of the color name like green, red, blue, you want to have some shades of that color. Okay, so you can use those hexadecimal code, and for that you can go to this page HTML color codes, and here, so if you see our color was this 444. So first we'll see what was so our color code is 6 times 4, not 444. So I'll just mention here 6 times 4. So this was our color. Now I think we'll change it to some other color, maybe bluish shade, and we'll take a different. Okay, so we'll copy this here and we will paste it here. Okay. So if you see here that this is again like this beauty of R Studio interface, that whenever you are putting the hexadecimal code, it automatically identify the color and you also get the idea, okay, you are using this color. Okay. Now if I run it again here, this code, okay. So that color was for this core sources for Bradford law. Now if let's make some more changes in this, let's say for example we want to add something like uh, here we want to as Bradford law NPTL. Okay, we'll add NPTL Bradford law. Okay, then what all we want to change is the more colors. So this white, and let's see if there are any other colors are there. That this is white, or maybe instead of this black we will use it as maybe cyan color. And now if I run this, okay, okay. So if you see here, what all things we have changed? We have changed this text, then we have changed this y-axis, we have also changed x-axis color. So if you see our earlier plot, it has this text and then this x-axis was in black color. Before that we have this logo was there, we have also removed the logo and this black color was there. Okay, so this is how you can play with this whole code, and that is why this whole package is open source and it's totally free. Okay, so I recommend that whenever you are using Bradford law or any of the computation in R or using its package, don't go with these three commands. Okay, what all those things we have done here. So if you see here, the whole Bradford law computation can be done with this single function. Okay, and you can just simply use it for your analysis. But if you want to make it a more beautification, and if you want to add some more thing and some more extra information into that, okay, so for that you have to use this code and you have to do some little changes in that. Okay, so this is all about the Bradford law computation. Now we will discuss about the second law, which is a Lotka law. So Lotka law is another popular law of scientific productivity. It was given by Alfred J. Lotka, who studied the author productivity. So what exactly he studied, that the number of author making n publication is about 1 by n square of those making one, and the proportion of all the authors who are making the single contribution is about to 60%. Okay, so we'll see that how we can compute in the R, that Lotka law. If you are doing this Lotka laws computation in continuation of this Bradford law, so you don't need to call this bibliometrics package. But if you are doing it from scratch and your session is new, so this package will call it. So our package code. Now we'll go with the data. We have to see the data. So to see the data, we will use this data function. And if I run this, so these are all data set in this bibliometrics package. Okay, and then there are like different other data set are there in different package. Now, so this we have already seen. If you are a beginner, you must try each time whenever you are using any of the law and you are using any of the test data set. Okay, so you can do this. Now if you go here, so in bibliometrics data there are like different data set are there. We will be using this scientometrics. Okay, so this Centrometrics is a data set of a journal Centrometrics. So we will be using this particular data set, and now if I run it here, again the same thing, our data is imported. What will be the first thing we'll do? We'll view the data set. So if we click here, so this is our data set. This data set has 17 columns, and then it has 147 entries. So then if you see here, it is source all Centrometrics because it's a data set of Centrometric journal, and document type is also article, and mostly like some of them are proceeding papers, but articles are there. Then it has those titles and other things are there. Now after we have viewed the data, we have get to know about that what exactly this data is and where we have to calculate this. So till now in the Bradford law there was only one function Bradford which calculated your all Bradford law analysis, okay. But here in Lotka law, in this particular package, it has two functions, okay. So we'll see the first function and then we'll see the second function. So that first function is the biblioanalysis, okay. Then if I run this here, and this is our package, so we'll put like this. So our Lotka law first part is done. So I am assigning to an object this. Now our second function is this Lotka, okay. So I am calculating like this. So this our whole Lotka computation is in the object Lotka result, okay. So we'll see the first class of this particular object. If we see here, it's a list. Again the same way the what the output of Bradford is. Now we'll see the what all names are there in this list element. So here it is like there are 6 elements are there. Here there is no graph, okay. So now we'll go by one. If I'll see the results, so this is the result. You see here that the number of authors with a single contribution are more compared to these 2 contribution and 3 contribution. So this is what the Lotka law is, and now we'll see like each element one by one. So I'll just run this. So again here we are using the dollar sign to access the one particular element of that list, okay. So how we are using it? Lotka result, and then dollar, and then author productivity, and if I run this here, okay, so this is the output. Then this is the beta value, then this is C, then if we see this, so this is our this value, then fitted value, then P value, okay. So done, our whole computation of Lotka is easily done with these 2 functions. So what we have done is we have used this biblioanalysis, and then after that we have made the Lotka law on this particular output. So here let us now again see the functions of Lotkas, okay. If I go here to Lotka, yeah, this is a Lotka, okay. Here it is, the all details are given what this Lotka function calculate. So the Lotka law estimates the Lotka law coefficient for scientific productivity. So we have already discussed theoretically in the previous week how what exactly the Lotka law is, and now this is that function is, okay. So this is the Lotka function, but before that we have used the function biblioanalysis. So if you do Lotka law on our that particular data set, it won't work on Scientometric, okay, or maybe another data set. So first you have to use biblioanalysis, and then you have to use the function this Lotka. So before this we'll go to the biblioanalysis. So our biblioanalysis function is here. So it is showing that this biblioanalysis, this particular function perform a bibliometric analysis of a data set imported from Scopus and Clarivate Analytic Web of Science databases, and then M is a data frame. So for biblioanalysis function, we require only one argument, okay, that is M, that is a data frame, and all those things are there, that authors and all those what all data it require, and this is a big function, okay. So the same way we can copy this code and we'll paste it here, and so this is our first function, a biblioanalysis. We have copied the whole function. So M is the bibliographic data frame and these are references. So we are not changing anything into the first function because that's a basic function of this particular package bibliometrics, and in Bradford, because we have to directly do the analysis on the data set, so we could able to do some changes and we can change the visualization and all those things, okay. Now we'll run this, and this time I am naming it as results. If I run this, okay, let us name it as 1 2, okay. Let us see how, if we copy paste, will it work. The same mistake. So this is a common mistake whenever like we are copying the code and when we are running it, and sometimes that without creating the function we are calling that function, okay. So you have to remember that whenever you are calling the function you must first create it, okay. That is why it's showing that this error is coming. So we haven't ran that function, so first we will create the function. Okay, now if I run this, again see, so this is a function in a package called as deployer, so we'll call that package also. On this, and now if I run this again, so it is done. Now if I like this was our another function for Lotka. So what was that? So this was a Lotka function. So I am just copying it and pasting here and naming it as a new Lotka. Now I'm running it this, and now if I see the output of this new Lotka function, and if I see, okay, the same output, okay. So this is how you can use the code of the package, whatever the functions they have created, and you can copy it and edit it according to your need. But you should remember that whenever you are doing like this, either you are editing or you are using the package, you must give the citation to that particular package or that particular software, okay. So if I see here on this page also, this license and details are given. So if you see here license, so this particular program is free software, you can redistribute it or modify it under the terms of GNU General Public License as published by the Free Software Foundation. Okay. So this is all about two of the laws, that Bradford law and the Lotka law. The another law, which is Gibbs law, I'll be discussing when I'll taking up the text mining, because Gibbs law is related to the frequency of a text. At that time, I'll discuss that particular law. Recommend that you use this Bradford law and change the color or maybe something text, and please let us know in the discussion forum if you like face any kind of difficulties in doing that. We will be very happy to resolve those things, or if any new thing you come to know, please do let us know. Okay. So thank you. We'll see you in the next week.